Okay, so I think I am up. People are tuning in, which is super nice. And I also just found a moment now. I should confirm on YouTube that I'm live. And okay, yeah, I am, and I can hear myself. Good. So, welcome everyone to this week's live stream over at Probabl. And this week I'm going to talk about a new project. This is not a project that I'm working on. A colleague of mine, Adrian, he's sort of in the lead of this. But Adrian has been working on this new plugin called joblib-modal. Now, for those of you that don't know, under the hood, scikit-learn uses this package called joblib that basically handles a lot of the serialization as well as parallel compute stuff that you might want to do in scikit-learn. In particular, things like grid search, those sorts of things we'd really like to do in parallel because those are like embarrassingly parallel workloads. But the thing that Adrian ended up doing is he started thinking like, hey, what other backends might we be able to attach to joblib? So I think right now you can do it on your own machine, but there's also a plugin for Ray. There's another one for Dask, and this is another one of those plugins, but it's for modal. Now, what is modal? Well, modal is a service that I've actually been using a couple of times. There's a talk I gave over at PyData Amsterdam this year, or last year, I should say. Run a benchmark, they said. It will be fun, they said. This talk is all about the annoying things you're going to want to deal with when you're doing a benchmark, and it's kind of easy to do that wrong. But one thing that made that work for that talk a whole lot easier was this service called Modal. I've been using some cloud stuff for a while now, but Modal does feel like it's one of the more likable. If you're a Python person, you can add a decorator to a function, and suddenly it can run on thousands of machines, kind of a vibe. That's kind of what Modal tries to do. Adrian is also joining us live, by the way, in case you're keen to ask questions. So what I figured I might do is just kind of give you an impression of what it's like to use Modal. And then I will show some of the stuff that joblib-modal, that integration, how that kind of works. And as we'll see, there's actually like a fun little, this is actually like a fun little project that I think is going to be quite useful in the long run. But okay, let's first do like the quickest demo of Modal, just so we can kind of get an appreciation of what that is. I'm inside of Jupyter over here, and what I'm just going to go ahead and do is source the virtual environment, right? So I've got a virtual environment started over here. This is a terminal. And over here, I've got this little script, and this is called Modal Demo 2. In a moment, we're also going to see Modal Demo 1. But this is basically like the quickest demo I could come up with that shows how you could use Modal. I've got a function over here called func, and the function really doesn't do anything that's interesting. But the one thing it does do, actually, just for maybe just for like dramatic effect, let's import time, and let's actually have this function do something like time.sleep 0, 0 point, I don't know, 3, some sort of number. So it doesn't really do anything, but it does sleep, so we can pretend that there is computation happening here, right? That's something that we could definitely convince ourselves of. But the whole point of Modal is that you can define an app, and that app allows you to decorate a function such that it will run on a server somewhere else on your behalf. So it's really that one function run that's going to happen on a server, and the result of that function can still come back to your own machine. And that's kind of the feeling that Modal really gives you. Now, what's the rest? This is just a function, right? And I've decorated it. I've also decorated it with some extra information saying like, hey, this one function can run in parallel, but only have 10 workers and no more. And then in the old school way of doing modal code, and I think this is changed recently, but what you would do is you would have a main function, kind of like app.local entry point. This would be kind of the old school way to make it clear that this function is the main entry point to the program. But then this function is decorated. So what you can do is you can say function.remote and then pass in the arguments. And this is going to indicate that a function is going to run right now. What you can do is you can run that function once and wait until a response comes back. You can also do that sequentially. But what you can also do, and that's kind of the cool trick, is you can also say, hey, I want that function to run in parallel. And there's this thing called map that allows, I think, just one argument at a time. But I'm using star map, which allows you to pass more than one argument into this one function over here. And you can see that I make a list of arguments on the inside, then I call star map. And effectively, if I were now to just run this. Like the old school way of doing this would be modal run, and then you would point to that modal demo 2 in this case. Yep. You should see that first the single call, a bunch of stuff is happening in the background, an app is starting, containers initializing. But now you can see that a single call happened, then sequential calls are coming in. Right? So, and this takes a while because there's like 20 of them. But now we're going to do the parallel thing. And this is going to come in a whole lot quicker than the serial stuff that we saw before. And that is because that is going to be shared across many different workers. There's not like a single worker that's handling all the code. We can just fan that out kind of nicely. This is basically what Modal does. And one thing to remember is there's all sorts of other stuff we can do with these functions. Like we can attach a GPU, we can attach a volume, and like a lot of that typical cloud stuff is stuff that you can expect. You can also declare a function like this that is then live in production, like you can do the Lambda function stuff. That's also something that you can do with Modal. But the first time I saw this, I was kind of like, oh, this is really neat. I can kind of come up with my own little Python program, and it kind of feels like writing Python as you would normally. But you do have access to some of this parallel stuff that you can go ahead and use. And it's just kind of nice if you have really big workloads. Suddenly, I'm still just writing Python, and I'm very minimally thinking about like cloud architectures and that sort of a thing. So as a practitioner doing data science and doing like very quick, needs to be mega parallel things, this is definitely like in the nice department. This was definitely like a cool thing. But, and I only learned about that this week as I was exploring this, you no longer have to write code this way. Like, I think up in like a year ago or so, the last time I looked at it, maybe half a year ago, this local entry point was the main way to do it. I think also like back when I used it first, that this app used to be called a stub. That's also something that has changed somewhat recently, I think like a year ago. But instead of having an local entry point, what you can also do nowadays is you can say, well, you need a context manager with app.run, but that is actually also sufficient to make it clear that this is the entry point of the program. And then you don't need to have a separate function that's the entry point. And when you do this, you also don't need to, like before, what I would have to do is do the modal run thing. But now you should also just be able to do Python. Why does that not work? Oh, wait, yeah, sorry. It needs to be demo1.py. This should now also go ahead and work. And you're gonna not see like that extra code that Modal provides, like spinning up the Docker container. That log information is not attached at the moment. But you can see that that code just ran in parallel just fine as well. So it's Modal is moving a little bit closer and closer to, hey, you can really just write Python files and functions, and oh yeah, Modal can kind of just do the thing for you. So this is using Modal from the command line, and it just works. And I hope people can look at this and appreciate that this is indeed kind of nice. But then the next step, of course, is can we also do this in notebooks? Because that's, you know, still my main interactive environment. I typically like to work in that because I have access to charts and stuff. But this is where Modal, at least at this point in time, I think is not, like, it's still got some features sort of kind of not 100% there. And that's also just kind of fine, but just to repeat the same demo, 0.3 I had, I think. Yep. Okay, so this is like the same demo I had before. It's just in a cell in a notebook now. And what we're going to see is I'm going to run this one cell. We're going to see that all of these remote calls to like a single function, that those all work fine. But this star map actually doesn't work just quite yet. I didn't investigate if there's a good reason for it. There probably is. But just for good measure, let's save the notebook and yeah, let's just run this. All right, so the single call is happening. Sequential calls are happening. So far, it's just the same as the script. All right, so I need to wait a little bit. And then I think here it breaks. Yeah, there we go. So there's an underlying like thing inside of here that's not allowing for this. I would imagine maybe sometime in the future, this will be natively possible, but you can't do this from a notebook just yet. That's the main observation. So, oh, Adrian suggested that with Modal enable output. Oh yeah, so I think what you can do, there's like an extra context manager that you can do here with Modal. I'm just gonna copy what Adrian said. Enable _ output, something like this. I think what we can do in Python these days is do like a comma here. So we have both context managers, right? Yeah, so when you do it, exactly. So when, this is kind of like a nice observation. Like it could be that you're still interested in having like the modal logs around when this happens. And in that case, you can just add this extra context manager. And in modern Python, we also have this cool thing where you can have like a tuple of context managers, and this just goes ahead and it all works. One thing to mention before we move on, I think, yeah, so this still breaks. One thing that will be good to mention here is I am using Python 3.12. I did notice for some of the stuff that I was doing, if I was using 3.10, stuff would just break. 3.11 worked fine, 3.12 worked fine, so just pick a 3.12 I think is like modern enough to sort of have as a default, but just be aware that some older versions of Python don't 100% mix well with some of the stuff that I'm going to be showing here today. But anyway, inside of a notebook, this might be fixed, probably will be fixed at some point in the future, but one thing that I did see is that, oh, the star map doesn't really work. And this is kind of a point where joblib can actually address that. But maybe first I should explain what joblib can do. And okay. Very high over introduction to joblib here. So normally, if you're doing grid search in scikit-learn, there is this number of jobs thing inside of the grid search CV estimator that you can just set. You can say something like, oh, just take all of my cores from there. That is behavior that under the hood is using the joblib library. And joblib actually gives you some primitives such that you can also write pretty good parallel code yourself. The typical loop you would write, it looks a little bit something like this. So you would have a parallel object as well as this delayed, I guess, it's a decorator, I guess, but you can also call it a function. But let's say I've got this function called expensive, and again, it's not really doing anything. It's just going to be sleeping. But a number goes in, and it's just going to sleep for a random amount of time. Well, what I can then say is let's turn that function into a delayed function. So this is a function that doesn't run yet, but it will run if it's going to be part of this parallel call, so to say. So this is a parallel object. It declares how many jobs we're interested in running. And then after that, we're going to give it all of these delayed jobs, basically. And this is a very standard sort of pattern or flow, you could say. This will run, and when all of those sleeping moments have been executed, you see I get something back. And this took longer than like 5 here. What you can also do though, and it's just a thing I wanted to show, because this is a thing that I found quite useful actually, is you can choose to return not like a list of executed functions. You can also say, no, this has to be a generator. And you can say that like doing that would require you to actually loop over the generator if you want to actually see the items. But there is a cute distinction that I just want to highlight. If you use this parallel class and you just return it as a normal generator, you will notice that what we get back here is definitely still in order. And you will also notice that if I were just to just run this, right? Items come back in, and let me just run that like one more time. You're going to notice that sometimes it's like a single item comes back, but typically a lot of this just comes still in like one fell swoop, and that is because I can only return item 5. Oh, let me put it this way. I can only return item 4 if item 2 is already returned, because this standard generator setting assumes that we want stuff still in order that we sent it into the generator. What you can also do, and there are use cases for this, is that you say, well, I don't care about the order as much, just I want to, whenever there's an item ready, I want to move on and do something with it. And in that situation, you want to return this as a unordered generator. So in a situation here, the order really matters. In the situation here, the situation of input is the main driver. So the order in which the input happens, that's the driver. And here the order of execution is going to matter more. So just to highlight that, I thought that was like a thing that's kind of underappreciated, but there are like tons of use cases for which this is super useful. Because now there are you no longer have to worry about the one item that takes a long while, but is like at the start of the queue that prevents other things from entering. That's a thing that's fixed if you are setting this item the right way. So this is just a parallel class. This is like a sort of relatively low level thing that you can use inside a joblib, right? But I hope at this point you also look at this object and you kind of go like, that's kind of general. That's definitely kind of nice. You can have normal Python code and then sort of almost do a asynchronous await kind of a thing with these generator for loops like this. And that's actually useful for a bunch of applications. You can also like do maybe something with a cache inside of this for loop, etc. Like for my main joblib tasks, I've actually found that sometimes it's easier to just use this parallel object than resort to the scikit-learn stuff that's built on top of it, just because this gives you like a little bit more control sometimes. So anyway, that's an object from joblib, and I also made some notes just to make sure I didn't forget to mention that. So joblib helps you figure out, quote unquote, the parallel stuff. So also like, how do I spin up workers? Like you may have noticed that I say that the number of jobs, like the number of workers that it can use is 8, so it can do 8 things in parallel. I don't have to worry about that. Joblib will just take care of that. One thing you might also notice in this case, this function has the function time.sleep in it. The worker also needs to be aware that there is this thing called time.sleep. So I'm importing something global here, but the worker is receiving that dependency as well. You can also imagine, oh, I've got this the main sort of thread, I guess, like the main process. It is sending data to the worker in order to do something. So serialization needs to happen. Oh, and then when the worker is done, I also need to get a data structure back. So it needs to be serialization back as well. It smells like pickling needs to happen there, right? So that's also why joblib has some features for that. And you know, joblib also tries to be kind of fault tolerant about all of that. And suddenly when you add all those things together, then you do kind of observe that, oh, it's just kind of nice that there's a library that's well maintained that takes care of a lot of that stuff. Doing all that stuff by hand is no fun. Another thing that's also kind of nice is that you can configure joblib to run all that stuff that I just showed you on a different backend. And historically, the main two backends on top of like your own machine have always been Dask and Ray. And you know, they've both got like some areas where they shine, but those were the only two main options. And what Adrian has been working on is adding like a potential third candidate, namely modal. The thinking here is that you don't, like, in these two cases, you would need to have like a Dask cluster somewhere or a Ray cluster somewhere. In this particular case, the idea would be you just have a modal account. And then you don't have to maintain your own cluster by doing this. You can also, I think, go to the Dask people or the Ray people and do like a cloud thing, and they will maintain a cluster for you, right? But the cool thing about modal is also that it can scale down back to 0 again quite easily. And I think, if I'm not mistaken, the idea with Dask and Ray is that you typically have like a farm with lots of compute available, but it doesn't necessarily easily scale down to 0. I could be wrong on that, but that's at least how I remember it last time I played around with it. Now, another thing that's also just kind of convenient is the way that it's set up. So if you want to use joblib-modal, the main thing you got to do is just do this importing. This sets up all sorts of things on the joblib side, such that joblib knows how to configure things. And then really, if you're doing something that's just kind of basic, the only thing you need is this parallel config context manager. And you just wrap whatever normal joblib parallel code inside of that. So you just have to say the backend is modal. You can kind of give a name to a job, which can be good for logging purposes, right? But this would already be enough to have our code run on modal. So I'm just going to go ahead and do that. And I think just for fun, I should be able to go to modal.com now and go into the dashboard. Yeah, we should see that there are like a bunch. Yeah, so there's a bunch of apps running, right? So these are all the jobs that I've just initialized, and a bunch of them have just succeeded. So, you know, yeah, the app has now stopped, and we can sort of go here, and we can see that like 100 function calls just ran. That's basically this one call I just made inside of this Jupyter notebook over here. And all right, it's giving me a warning, but I think we're fine. But this is kind of like the nice little feeling. It really feels like I barely am aware of a cluster at all. But I do have good old joblib, and I can reuse that parallel primitive that I had before. And that's like a very nice feeling, simply because this parallel primitive covers a lot of ground, really. Like if you can do lists and generator stuff with it, and all that stuff can run in parallel kind of in an async way. Oh, gee, that's gonna make a lot of my expensive notebooks run a whole lot quicker, because it really still feels like I'm writing base Python. There's no, like in the background, one thing to know is that I did log into Modal, and there's like an authentication key on my device. Like there's some connection you got to make, but that's pretty easy. You just do that from the terminal once, and you're good. From then on, life is nice. And the result I get back is a Python list, as you would expect it kind of normally. So, pretty good. We now have a modal backend for joblib. So let's now talk about, okay, this is like a cute little demo where I have a function that just sleeps, right? So that's, it's cool to get sort of the big idea going, but this is not how you would actually use it. Oh, and Adrian is making some comments, and I do want to listen to Adrian because he made the thing. Yeah, so Adrian makes a fair point. So there's this number of job setting over here, and I've been sort of mentioning workers there. But the better way to say it, typically, if you're not like workers, makes sense in like a very general setting. But if you're doing it on a single machine, then it's basically translating the CPU cores. It's not necessarily a worker; it's definitely CPU cores that are happening there. And yeah, there's this like hyper-threading details as well to be aware of. That's like a fair comment. Oh, okay, and Adrian is mentioning, Adrian is maybe a bit more experienced with Dask, but the people over at Dask, there's a company called Coiled. They have made some cool stuff, but I just don't know. I haven't really used their product. But if I just real quickly, yeah, so this is like a very minimal viable example, of course, right? But it does feel like, oh, okay, like the modal way, sort of, the modal way of doing it is saying like, here's just a function, but I guess looking at the coiled code over here, there's still clusters involved, but it also seems like you can just whip up a cluster and turn it back down again. So in that sense, it's still kind of like a Lambda feeling, which is not too different from what we're doing here. So I might need to explore this coiled stuff a bit more sometime later, because coiled has, when it started, it was kind of like Apache Spark, but you didn't need all the JVM stuff, and that kind of felt nice. But yeah, my impression is that a lot of geospatial people like coiled, because it also has like parallel stuff for NumPy, and that's sort of that's like a feature that they've got. Anyway, Adrian's making some good comments there, but the main thing is like you can somehow also get like a Dask cluster working here. It's definitely fair to point that out. But anyway, the point I want to go towards is that in the demos that I've made so far, I'm just really taking a Python function, I'm telling it to go ahead and sleep, which is cool for demos and showing that stuff is indeed running concurrently, but it's not necessarily a realistic example. And for a somewhat more realistic example, I figured I might just do grid search, so to say. But if you want to do grid search inside of Modal, there's a couple of extra things you got to do. In particular, right, if you're using just a base Python function, like something that only uses the internal libraries, then you don't need to do anything to like a Docker container or like the environment, so to say. But if you're doing anything with scikit-learn or NumPy, well, then Modal needs to know how to set up the environment the right way. The way Modal tends to go about that is there's this idea of an image. That's not the same as a Docker image, by the way. Like, I think there's a distinction. But in short, what you can do is you can say, well, I want like a slim variant of an image. And then I want you to pip install a couple of packages. And because I'm going to do something with scikit-learn, scikit-learn needs to be installed, NumPy, joblib, scipy, we want specific versions. This is kind of like a nice trick that I found on the joblib modal docs. Like, you can just import the versions you've got locally, and once those are imported, you can reuse those versions here, and that's kind of nice because it also kind of guarantees that if you're going to do serialization back and forth, that whatever you get back from Pickle or whatever serialization method they use, that's just kind of compatible. It'd be kind of a shame if on modal side there are like NumPy functions that you don't have locally, and that might break something, let's say. So this is definitely like a good habit. So, but anyway, that's a definition of an image. I believe, again, it's not Docker, could be something else. But you can, Adrian was also mentioning it, you can pass it a Docker build file, like it does understand it. What you also can do is you could run some shell commands. We'll see an example of that. And that's a way that you could use UV if you really wanted to. But we do have like an image abstraction. So even though this might not exactly be a Docker image that's built, for all intents and purposes, it does give us like an arrow that we can point to a thing that has like dependencies installed. That's the main thing that we care about in this case. So, okay, I've got some sort of image that has all my dependencies in it. I've also got a parameter grid, because I'll be doing a grid search. It's like a thing you want to do. So I've got like a learning rate. I've got like a maximum depth. I've got a random state. Yeah, optimizing for a random state is not a good practice, but I figured, why not? And I've got my classifier here, and I've got my randomized search object over here. This parameter grid goes in, and I can also manually tweak the number of iterations that I'm interested in doing. And I've also got my make classification function call over here. So this is my X and Y pair. I'm going to do grid search on this. It's not the hardest data set also, by the way. But then we still have the same pattern effectively. So I'm still using a parallel config. I'm still able to say, hey, the backend is modal, but there is some extra stuff that I can set here. Mainly that image. That is something I can pass along. And that's also something you really need. I can also say, hey, don't give me that modal output. That's something that would otherwise show. I'm just explicitly turning that off for now. And kind of the thing that I really appreciate here is that I can just run that as I would normally. Right, so this is now all defined. I can also just run this as I kind of would normally. I'm just gonna see how long this takes. It might take a little bit of time. Okay, so this takes 9 seconds. The reason why it doesn't take too much time in this particular case is because this image is already built. Like the image building part can take a bit. I think if I set a number of jobs here, joblib-modal does actually set it to 50. I think I recall reading something like that in the implementation. But the main thing I kind of want to show is, okay, let's just double this number, make this number like way bigger. Let's set this to, I don't know, 50, right? This took, so before we had 20 jobs, that took 9 seconds. Now we're going to set 50. Let's run this, and then I can also go back to modal, right? And then, is this the latest one? Just refresh. Yeah, so this is the live app. Oh, and it's already stopped. Okay, so maybe you need to go for something heavier. But effectively, it can fan out and it can do the parallel thing. That's the main point. So before we had 20 jobs, it took about 9 seconds. Now we have 50, and that took about 12, maybe a bit less. So that's kind of the cool feeling. I can just change a single number, and all that parallel handling is taken care for me. Oh, and Adrian is pointing out that there is actually a default enforced by modal in this case. So 100 is the default that modal gives you, and inside of the code, we set it to 1,000 in parallel, which I think is a reasonable default, actually. But yeah, if I can just maybe new keyboard setting, there we go. Let's set it to 200. This should definitely exhaust the amount of parallelism that I can do. And I should also be able to go to the live app. And we can see that there are a couple of containers definitely still running. This is live, right? So there's a couple of containers running. There's a couple of containers that have already started. There's a few that have already stopped. And there's a couple of them that have succeeded at this point. At this point, they've all kind of succeeded. But yeah, definitely good success rate. And yeah, it's, again, like, the grid search here that we're doing is like ridiculously small, right? Because X and Y, those are small data sets. But the main thing that is hopefully kind of clear, it's just a context manager that we wrap around code that we would also write as we would normally. And that's just kind of a like a nice direction. That kind of feels good. I do want to mention like one thing that this code doesn't do at this moment. And it's kind of like a detail in a lot of ways, but it's good to point out. Because there is a little bit of magic happening here, and that's related to this XY pair. So normally you would have like your own your laptop. Just gonna draw kind of a silly laptop and write laptop. Great, eligible writing. And technically, what's happening here is it's just totally fanning out, right? So we've got tons and tons of workers. I'm just going to use the word worker. Like how workers are exactly spun up, that stuff is all handled for you. But one thing that's, of course, happening under the hood is that we're not just sending our code to the worker, like the stuff that's got to execute. In this particular case, we also have to send the data. And you could argue that maybe if this is like a proper big data set, maybe we don't want to send our data from our laptop to modal every single time. Instead, what you might want to have on the modal side is have some sort of a volume, like some sort of a disk that's just close to the worker, and maybe you can give the XY pair that way. Right, like that might be like from architecture point of view, that might be like a way better idea. A lot of this depends on like how big your XY pair is, of course. And one thing that is, of course, a little bit annoying is that, oh, if you actually want to manually read the data in, then maybe you got to resort to like a specific modal function there. But you can imagine that this is something that might be explored as well for this parallel config modal integration. The dataset stuff. But that is something that, of course, is also happening under the hood here. Like it's a little bit magical that it works as it currently does, because it feels like you're just writing a Python script. But it is good to be aware of the fact that under the hood, of course, some of its stuff still needs to translate over the wire. So Adrian is thinking about this. Like he really just made this release on Monday last week or something. Like this is definitely like new stuff. But there is still work that could be done in terms of this parallel configuration that I did want to just kind of highlight. But yeah, that grid search object, it has a, let's just check the shape. It has a bunch of hyperparameters, thing that I checked for, and it has like 200 numbers that I could go ahead and use. So this is hopefully for scikit-learn people like a clear example of something that is kind of like super duper useful. If you're interested in doing like personal experiments, setting your own thing up on Modal is way easier than setting your own thing up on AWS, just in terms of permissions and all that. I was thinking though, like, okay, it's cool that we can do this sort of the standard scikit-learn thing for parallelism. That's definitely like a nice win. But I was kind of wondering, like, okay, can I use this joblib integration for something that goes beyond scikit-learn? Like, it feels like we have parallel powers now, right? Like, what else could I do with it? And then the task that I usually deal with, that I figured I might just show, is embeddings for sentences. Like, I still do a bunch of NLP now and again. And part of me was always a little bit disappointed with just the amount of compute that I got to use to embed some stuff. And it's like fine in a way. Like I have an M1 machine, like you can run it and it does do its thing. But sometimes it takes like a minute, and I would prefer it to take like seconds instead. So part of me was thinking like, hey, maybe what I could do is I could use joblib to do embedding stuff for me. Like, is that practical? So I came up with this other little demo that I thought was just kind of cute to show, because I did learn something that is potentially interesting while trying this out. So I've got the CSV full of sentences, and I'm only grabbing like 50,000 of them. And you know, these are just really sentences. I think they're from Reddit or Archive or something like that. They're not that special. They're just sentences. And what I figured I might do, like, let's have a function that can batch all of those items. So let's make batches of 1,000 each, let's say, right? And then there might be a partial batch, but this function takes care of like taking the batches, and it effectively just gives me a generator. So I can keep calling next, 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 and it'll keep on giving me a batch of sentences that I would like to get embedded. And I would also like to use sentence transformers. That's a good library for this. So okay, I've got this generator that's going to be able to generate me all of these batches, and I know that the parallel object it can do this. It can definitely deal with generators and stuff, so that's good. And here's then kind of the code that I ended up with. So I've got this embedding model that's a constant, and kind of the thing that I thought was clever. When I make the image for modal, I am pip installing sentence transformers. But what I don't want to have happen is every time that I send like text to that worker to embed, that I don't want it to download the big heavy embedding model. I kind of want that to happen once and only once, because otherwise, like most of the compute time is just going to be spent downloading a embedding model. A trick that I have found to kind of work there, like you could do the volume thing. That wouldn't be like a bad idea. But in this particular case, what you can also do is you can tell that image to go ahead and just run a normal Python command. And with Python-C, you can actually give it like Python code to actually run. And you can say, hey, from sentence transformers, import the sentence transformer, and then create an object that loads the embedding model. And in doing so, it is also going to download that model, and it's going to be part of the image now. So you'd still kind of like, you can still maybe go a step further because you kind of would like this function to already have that sentence transformer loaded in memory, maybe. But at least we have it on disk. I figure that would be like a good first order improvement. So also just as an example, like sometimes you just want to have something loaded from Python, and that happens whenever you trigger something from within a Python runtime. If that's the case for your project, then this is a trick that does kind of work. You can at least make sure that it's on disk inside of the image beforehand. So anyway, that takes care of this image, and then I've got this embedding function over here. I'm importing the sentence transformer from within this function. I forget the details, but this removes a lot of bugs, and also it's kind of okay if it loads from within this function, because this entire function will be sent over the wire. Yeah, like it's really basic. Embedding model loads, and we encode. That's the thing that's happening here. So, okay, that's everything in terms of setup. What I then did is I basically told joblib, okay, I want backend to be modal. Here's the image. Don't show me the modal output. And I'll make batches that are like 1,000 big, 50,000 sentences, and that takes about 40 seconds. That's something that seems to be happening here. So, all right, that's not the worst. That kind of feels somewhat pragmatic. There's definitely like some overhead involved, and okay, so Adrian was responding to this. Like, I think Adrian is mentioning that the error that was sort of causing this, that was apparently something on the modal side that they've since fixed. So I think I should be able to do this. Either way, this is also fine. There's no, I don't think there are big problems if you do it this way. But it's good for Adrian to point out that there was a bug that's now been fixed by the modal folks. They were kind of on top of that real quick. But anyway, like the main thing I want to show is that when I do this, I do get like a NumPy array out for 50,000 sentences and like the right dimension for that model that I've got. But the main thing, again, is that it's still, oh, I have a generator with inputs. I have a function. This just goes ahead and works, and I can use this from a notebook. Even if doing this with pure modal is kind of tricky inside of a notebook, just because we have joblib, we can already do it right now. So that's awesome. But then you do start wondering, you know, can we, like, what can we do to maybe make this a bit quicker? So one thing I was wondering, like, can we do something with the batch size? Like, can we make that maybe a bit smaller? So I tried it again with like a batch size of 500, and I got like roughly the same speed here. So, all right. What happens if I make the batch size way smaller to 250? And you know, it's not like way smaller, but at this point I do feel somewhat comfortable to say this is at least it's measurable, right? But there is this balance between you can maybe fan it out as much as you can, and then the overhead. There's still a little bit of overhead involved with starting up a function, I suppose. But there's a balance, I guess, that you can try to figure out. And I don't know, like this kind of felt pretty okay. But then I started wondering, like, okay, I'm using CPUs here. Like, I'm not, like, I'm doing something that's very heavy tensor compute style stuff, but I'm using CPUs. Like, maybe it'd be better if I use a GPU instead. At the moment, there's no way to, there's no way to really nicely configure that from the modal joblib integration. But what you can do, like, the thing that didn't work for modal inside of a notebook was the bit that does the stuff in parallel. That's the thing that didn't work. But calling a single function, that worked just fine. So then I started thinking, like, what I can also do is just, again, you come up with an image, and then again come up with an app. Like, this is kind of like the modal syntax, right? Like, you can declare an app and immediately attach an image to it. But what I can then do is just have one function call just once, send all of my texts in there in one go, but that one function does have access to a GPU. And the way you would configure that inside a modal right now is you would say, well, I've got a GPU. You can have different kinds of GPUs. I'm going for an A100. You can also go for an A100 that has more gigs of memory. But this, I don't know, just picked one. And yeah, I figured this feels like a cute thing to try. What's quicker? Like an ocean of CPUs that can run in parallel, or a single function that has access to a GPU. So I ran it, and it kind of it's all in the same ballpark, it seems, that I thought was just kind of an interesting observation. Although if you really take like a small batch size and you're able to fan out like proper, it does seem that this is like a little bit quicker. A lot of this depends. I do want to stress that. So the encoding that I'm doing is on short sentences. If I had longer sentences, probably there'd be like more tokens and therefore more tensors need to be multiplied. So like that could be a thing that keeps we could keep in the back of our mind. Adrian is saying something though. Let's see if you could modal function args. Oh, hang on. There's an interesting thing that we can do. So Adrian is suggesting that one thing that we might be able to do is add like modal function args like this. I am hoping Adrian is following along at this point, so he can help me. Yeah, but can we also do quargs? That will be the main thing I'm interested in, because then I can just do a GPU colon a 100. If we could do this, that'd be ideal. Let me just make sure I ran the code. I don't know if I actually ran this, so let me just run that. Yeah, okay, that works. Yeah, let's see if this works. Batch items is not. Oh, I need to run that function above. I need to run both of this stuff. Because this is, yeah. Yeah, so this doesn't initialize. For some reason. So Adrian, unless you see the obvious. Oh wait, I think I can just do this. Can't I just do GPU equals A100 here instead? If this doesn't work, I'm going to move on, but I just want to... If this does work... No, it also doesn't seem to work. So so just to check, Adrian, am I doing something wrong here? Because I think what I've got over here should work, right? Just checking if Adrian knows. If he doesn't, I will move on. Yeah, exactly. So this doesn't work yet. This is a thing that Adrian can add though, and I do think being able to do this in parallel with GPUs will be cool. Yeah, this is just doing the CPU thing. But one thing I thought was just kind of interesting and cute is that it did at least seem that it seems plausible, maybe not always practical, but it did seem at least plausible that there are these moments when having an ocean of CPUs is faster than an ocean of GPUs. And that actually made me wonder, like, can I also maybe do something, like, can I also check if this is more or less expensive? So this is super back of the envelope calculation, and I'm probably, this is not going to be the most accurate, but if I just look at the pricing page of Modal, right? So there's a pricing page there. There is a price for the CPU and there is a price for the GPU, and what I can do is just look at the logs and say, and like, how long does a CPU function take on average? Multiply that by the parallelism, and how long did it take for this guy to run? You know, so the GPU thing ran for 40 seconds, and if I multiply that by the price, it seems to like encoding 50,000 sentences to cost like 3 cents. If I compare that to the cost of the CPU, which is way cheaper, like I had 200 of these jobs running, and then I have to multiply that by 2 because it takes 2 seconds on average for each job. And if I multiply that by the price, it seems like that's 1.5 cents. Now, the only thing I want to suggest is that it might be competitive. I don't want to suggest that these are the most accurate numbers. I talked to the Modal people about it, like, how is it possible for me to actually pinpoint this job, how much money that costs? And there's like extra things involved here, like how much memory did you use, and like startup time and cold and hot state and all that sort of stuff. So take these numbers with a grain of salt, but I do think it's interesting that you could theoretically come up with these jobs that, although theoretically could benefit from a GPU, don't necessarily have to, because you might have an ocean of CPUs available instead. I do think that that's you know, something to at least keep in the back of your mind. I was slightly surprised by this, but you know, it seems like an interesting result. So, the joblib integration right now. There's a few things that it doesn't allow you to configure. The GPU is something that I've mentioned. Datasets is something that I've mentioned. I think there's also another thing you cannot set right now. So I think modal and default takes like a 5-minute timeout for a function to run. That can be fine, but there are these moments when you need more time. I could be wrong. Aiden can comment on this, but yeah, like the timeout is also something you can't configure just yet. But I'm assuming that after this, like Adrian is watching along, so he's looking at this and going like, "Oh, I should probably add that." But I do hope that people can appreciate both. Joblib is just kind of nice because it's this, in my mind, kind of an underappreciated tool. But I also hope that people can look at this and kind of go, "Oh, Modal is a likable cloud provider, and having this integration can actually open up a few doors, especially if you're keen on keeping your work inside of a notebook when you're exploring." I think that that's kind of like the main use case. That will open up like a few doors to people. I'm someone who's like quite comfortable using joblib Lego bricks, so to say. I really like the generator stuff. That's just something that I've always kind of liked. I really like the idea of, whenever the first thing comes in, first out, I can totally write my code kind of more in an async way. That is stuff that I totally do appreciate. But yeah, I will put this on our GitHub so people can sort of play around with it. If you haven't already, check out the GitHub. So Adrian Jalali /joblib-modal. There's only a few stars at the moment. Like, feel free to add like a star there if you're interested. This is just a cool thing. If you're going to be doing parallel stuff, even if it isn't related to scikit-learn per se, like one thing that I was actually sort of wondering, like, I think I'm probably not going to do it, but there is this library that I made like years ago called Evil. Yeah, and Evil is a library for evolutionary algorithms. It has a nice API. It's just that I made the library because I like the API, and then I realized that I didn't have a use case for it, so then I stopped kind of maintaining it. But one nice thing about genetic algorithms is sometimes you've got all these candidates and you want to maybe evaluate them, and sometimes you need to run a big simulation in order to do that, especially if you're doing things like card game simulations and stuff like that. Oh, and that evaluation is now something you can totally do in Mega Parallel. Oh, that's actually kind of nice. So, like if I ever find the time for, like one thing I might do quite easily now is just add joblib support to Evil. Because if I add joblib support, I also suddenly get modal and Dask and Ray and some of those other ones. But the fact that I was actually pleasantly surprised that Adrian was able to get the modal integration working so quickly. But it also like highlights the fact that joblib is kind of flexible. So that was like a super duper nice lesson. So that's the main thing I just wanted to show. I hope that was useful to a lot of you people. If you would like to discuss this stuff more, do observe that we have a Discord. Go to discord.probabl.ai and you'll be redirected to our Discord where you can talk to us. Next week I will be back, and it's not 100% set in stone, but I think I might be having a look at Prefect. That's like a thing to look forward to. Prefect is a workflow orchestrator, and it's kind of like a data engineering kind of a topic, this one. But I think that there are a few things that they do that might be interesting to look at, because some of the stuff that they've built is also meant for machine learning in production. And this might be a thing I explore next week, so hopefully that's kind of interesting. And I kind of like this tagline of Airflow is built for 2015, Prefect is designed for today. We'll see how well Prefect actually is, by the way, but I do agree that Airflow did come from an era that's just a little bit different than it is today. So it might be good for us to also look at some of these engineering topics as well. I'm going to be on for just a few more moments just to see if there's extra questions, but the main thing that I hope is that this was like a useful demo to people, and that, if you haven't already, that you're going to have lunch and have a great weekend, and that we'll see each other again next week. Oh, one final thing, I guess, that does kind of pop into mind now. So if you go to the Probabl YouTube, you should see a new. Check out the new podcast that we released yesterday. What I'm hoping to do a little bit more of is, like when you're growing a podcast, it makes total sense that you invite celebrities, because then the podcast grows because people notice celebrities and then they're gonna, hopefully sign up for the podcast. This is an instance where the person that I'm interviewing is not necessarily a celebrity, but he has built a really useful trick that will definitely help speed up word embeddings. Like, there's a distillation thing that he does to turn transformer models into word embeddings without losing too much predictive power, which is a super duper cool trick. It's the models effect trick. I've also done that like 2 months ago, I think, in one of the live streams. But there's some insights on like how the thing got made in this podcast. So if you haven't listened to it already, I do recommend giving that one a spin. Note that you can also listen to our podcast on your favorite podcast player and look for sample space. But it's a really cool interview. I wish more people would listen to it. We've been getting lots of good compliments. So check that out. Thomas van Dongen. He's working on cool stuff. So yeah. It seems that people are leaving, and that's also totally fine, because also I feel like having lunch. Thanks everyone for tuning in, and yeah, hope to see you soon. Going to my OBS app and hitting the end broadcast button. Y'all have a good one.